morning. Today we are going to see about Internet of Things and its applications. What is Internet of Things and why it is called Internet of Things, and how we are going to utilize IoT in different areas, and also what are the components of IoT and how it interconnected in Internet of Things. Hello everyone. Today we are going to see about introduction to Internet of Things. Many of us are heard about the names called IoT, that is Internet of Things. Uh, Internet of Things refers to a physical object or devices embedded with sensor or software that has connective capability, that is enabled to collect data, and it able to transmit or over the internet or some other network. Many of them thinking about Internet of Things is about only connecting the things in the internet. It's not like that. If you are connecting the things through other communication medium, it is also called Internet of Things, IoT, coming under IoT. Here we need to clear about the term called things. Things means it may be a device, or it may be a simple system or complex system, a simple embedded system or complex embedded system, or it may be a sensor, or it may be a development board like Arduino, Raspberry Pi, etc. etc. So things may be a system or device or sensors. System may be a simple system or a complex system. And these are all the examples of things as you are seeing in slide. So where we use Internet of Things, almost all the areas, as you see in the slide. In for home automation, we use IoT. For transportation, we use IoT. For retail and household shops, we use IoT. For agriculture, we use IoT. For industrial automation, that is smart factories, we use IoT. For power transmission and distribution, we use IoT. In healthcare uh, sectors, we use IoT. Almost all the areas in mechanical system, in automobile, etc., etc. So that is not shown in your slide, but in automobile industry also we use IoT. As you know, that is vehicle to vehicle communication is coming under IoT only. So as I said, uh, Internet of Things is connecting the things through the internet as well as other communication media. For example, if you are connecting the things, we know what is things. It may be device, or maybe a system, or it may be a sensor, or it may be a development board. So if we are communicating, or if we are connecting the things by using other communication medium like Bluetooth or Wi-Fi or LoRa or Zigbee, that is also coming under Internet of Things. Internet of Things not only focusing about internet. Internet is one of the medium, and other communication protocols is also coming under IoT. So things may be a simple system or device or sensor or simple embedded system or complex embedded system. So embedded system is a main part in your IoT. As we know, embedded system is controlling the hardware with the use of software. And this is the main block diagram of embedded system. As you seen in the slide, the main block, the first block in your embedded system is sensor. The sensor is a device which converts a physical quantity into electrical quantity. Why we need to convert a physical quantity into electrical quantity? Why? Because suppose if you want to process a data or a physical quantity or any quantity, it must be in electrical form. A process in the sense, you may have a question. What is maybe process? Process in the sense, if you want to store some data anywhere, maybe hard disk or some other uh, device. If you want to store and retrieve a data, if you want to amplify a signal, if you want to transmit your signal, it must be in electrical form. So now you can clear with what is my processing. So if you want to process your signal, it must be in electrical form. So sensor is a device which convert your physical quantity into sorry, electrical quantity. So normally this converted electrical signal in analog form. But the processor and controller is a main part of the embedded system which can understand only digital form. So you need to convert that analog signal to digital signal. So for that you can use a chip called ADC, that is analog to digital conversion. So after the digital conversion, the processor has the program designed by the embedded engineer. So based on the data, the processor gets the data from the sensor in digital form after converting into ADC. Based on the program, the data can be executed. And again, it should be converted into digital to analog form. That can be done by the DAC. And that analog signal will feed to actuators. So actuators normally it's an output device. It may be a display or it may be a motor, etc. etc. So as I said, sensor. So now we are going to see operations of different kind of sensors. As I told in first slide, the previous slide. The sensor is a device which can convert a physical quantity into electrical quantity. Physical quantities, for example, what are the physical quantity? It may be a pressure, or it may be a temperature, or it may be a motion, or it may be a voice, or it may be a humidity. Everything is called physical quantity. These are all the different examples of physical quantity. Suppose if you want to monitor one physical quantity, suppose you want to display one physical quantity, you need to have a particular sensor. For example, if you want to uh, monitor or display humidity in the room, you should have a humidity sensor. Suppose if you want to monitor temperature, you need to have temperature sensor. Okay, first we start with temperature sensor, and here we have seen we are seeing four temperature sensor. We have many kind of temperature sensor. Out of many temperature sensor, these are the most widely used temperature sensor. Here the thermistor, the first one is thermistor. The thermistor, we have some material in thermistor. The material in the thermistor which can change its resistance when the temperature changes. As we know, if the temperature changes, the resistivity changes, linearly changes. As we know, if resistance changes, the voltage varies. We connect one voltages along with the thermistor. There's a change in resistance, there's a change in voltage, and that voltage normally taken as output voltage. The change in voltage according to the resistive variation. So we convert your temperature variation into voltage variation. Temperature variation into resistive variation and the resistive variation into voltage variation. So we can have a exact output voltage as uh, for the temperature variation. Next, RTD. This RTD is we use a platinum material. It is very expensive material. It is also accurate material in which you can find this temperature with a good accuracy. So normally the RTD is used in research laboratory and industrial process control and some kind of medical equipment. Next, IR sensor. Suppose if you want to calculate a temperature without contacting the material, you can use IR sensor because every material radiates heat in the form of infrared. So the infrared sensor detect that IR rays from the material. Based on IR rays, it calculate the temperatures. And the last one is IC semiconductor sensor. So we can have a temperature sensor in IC form also. So normally we use some portable IoT device uses this kind of semiconductor sensor. This ultrasonic sensor. So ultrasonic sensor, uh, it has two main things, that is ultrasonic signal transmitter and ultrasonic receiver. Normally the bats are using ultrasonic waves to find the obstacle in their path. The same principle we employed here. Ultrasonic waves, the ultrasonic sensor transmit ultrasonic wave, and if there is obstacle in their path and it get reflected by the obstacle, and that reflected signal is received by the ultrasonic sensor receiver, and it calculate the transmitting time and receiving time. Based on this calculation, the sensor find the distance between the objects. Next one, photoelectric. Normally, the ultrasonic sensor based sensors are used to find obstacle detection or liquid level sensing or distance measurement. Next, the same principle, but instead of ultrasonic signal, you can use light. Same principle. The light transmitted from the source and it get reflected by the obstacle, and the received signal collected by the receiver. Based on the transmit reception time calculation, you can find the distance. And also capacity. We know the capacitance. The two conductor is filled with a dielectric. It is act as a capacitor. If any change occurs in the conductor distance, there is a change in capacitance. By using this principle, you can find the distance of the objects.